The boundary between reality and simulation has vanished. Today, we dissect Apple Vision Pro 2.
We are inside the glass shell. Behind this exterior lies a symphony of sensors tracking every movement of your gaze and your hands.
12 cameras, 6 microphones. Its LiDAR scanner. Dual Micro-OLED. More pixels than a 4K TV, packed into a space smaller than a postage stamp.
The Pancake lens. A folded optical path that compresses light, letting us look at a giant screen while keeping the device slim.
Precision. If the lens is off by even a nanometer, the entire virtual world drifts.
Eye tracking. The infrared ring tracks your gaze in milliseconds, allowing the device to render only where you look.
The R2 chip, the spatial brain. It processes sensor data independently, ensuring zero.
Processing spatial data is a fire-breathing task. Keeping the R2 chip cool while it sits against your forehead is a thermal engineering masterclass. Eyesight, a lenticular display that creates a 3D illusion, letting others see your eyes. It's a bridge for human connection.
The hinge is the silent hero. Tens of thousands of cycles, perfectly weighted so the headset feels like a second skin.
The headband, woven fabric to distribute weight evenly, making hours of spatial computing feel like minutes. Spatial audio. The headset maps your room's acoustics, turning every corner into a virtual soundscape. MagSafe power. Simple, secure, and infinitely swappable for the professional who never sleeps.
The optics are aligned. The spatial world is ready to be painted.
This is not a screen. This is a canvas for human imagination.
Reality reimagined. Every floating window is a testament to our computational reach.
Spatial anchor, locked.
The finish. Every curve is polished to nanometer perfection. We've redefined what is real. But what drives this engine? Join us in part 2 as we dissect the R2 chip's neural logic.
The R2 chip. Beyond raw speed, this is a dedicated neural spatial processor. It handles
Spatial mapping. The headset doesn't just see the room, it understands the geometry. Every surface, every corner is mapped in 3D.
LiDAR pulses map the depth. The R2 chip processes this data to ensure virtual objects have physical weight and permanence.
Low latency inference. This chip predicts your hand movements before you even finish the gesture.
Digital persona, the most complex challenge in spatial computing, creating a photorealistic you.
Subsurface scattering. We aren't just drawing a face, we are simulating the way light interacts with your skin.
The R2 chip tracks 50+ muscle points to mirror your humanity.
voice isolation.
Avoid in a busy street. Even in a busy street, the R chip strips away the world, leaving only the clarity of your
Light estimation. The headset analyzes the room's light to match the virtual world, making the simulation indistinguishable from reality. Engineering silence. Active cooling that you can't hear, ensuring the R2 chip pushes boundaries without breaking a sweat. Optic ID. Your iris is the key. Encrypted, hardware locked, and impossible to replicate.
The total system latency, from your movement to photon reflection, is under 12 milliseconds, faster than the human brain can perceive.
Spatial computing is not an object. It is a seamless integration of human intent and computational power.
We have built the mirror of the digital soul.
The hardware disappears. Only the experience remains.
Evolution. Driven by first principles. We are just beginning to see. Subscribe to See Beyond. Next episode. Hypersonic propulsion test. Mach 5 flight.
Would you live in a digital world? Tell us why.
End of dissection.